This is Gaurav Gulati. This is part two of my final project presentation on Microsoft Cognitive Toolkit (CNTK) for the Big Data Analytics course at Harvard Extension. This is a more detailed presentation compared to the last one, as the previous one was time boxed at about 2 minutes, but we're gonna have a little more time this time, so we're gonna go in greater detail. So I'm going to go through my problem statement again. So we have a image database of banknotes that has then been um, transformed through an image wavelet transformation and metadata generation process. The output of this process is then fed into a feed forward neural network, and then this neural network then classifies the output into authentic or counterfeit notes based upon the metadata that was supplied as features into the algorithm. So um, typical binary classification problem, and the technology stack that I have used is Microsoft CNTK version 2.3. This is the latest and the greatest released. I believe it was only released a few weeks ago. And then I have Anaconda 5.0.1, which comes with Python 3.6 and Jupyter Notebook 5.0.0. The operating system was Windows 7 64-bit. The CNTK supports Windows 7 64 or Windows 64-bit platforms and Linux-based 64-bit platforms. It doesn't offer Mac support yet. I do believe, based upon some online research, that you could get a Docker image with CNTK that can run and work on a Mac, but it's officially not supported. Why CNTK? So as part of this project, we had to select a technology that we didn't really discuss or learn in class. I chose CNTK because it's Microsoft claims that it's 5 or 10-fold faster than TenFlow, so speed was a factor. Also, it was a Microsoft technology, so I wanted to, after leveraging or learning about so many other technologies, I wanted to see what Microsoft's doing in the machine learning space. Also, the overall setup and readability and ease of use of the platform was something that I liked about CNTK. The extensibility and the extensive integration, API integrations with Python, was also something that sort of drove me towards selecting CNTK, and finally the C# support. Although I didn't really use any sort of C# programming at all as part of this final project, but again, um, this one is for the C# enthusiasts, and I've had a lot of programming experience with C# myself, so that was the underlying selection criteria. But again, besides that, and there's a whole bunch of other benefits or value props that Microsoft has come up with around CNTK. I don't necessarily agree with all of them, but their website cntk.ai has additional details on how CNTK differentiates itself from TensorFlow. Okay, but that being said, what I was disappointed was with the limited support around CNTK. It's definitely a very new technology, and there are not a whole lot of resources out there besides just what's there on the Microsoft site. It's overall buggy. I really had a hard time with CNTK cooperating with the matplot libraries with Python, and that was really sort of a deal breaker, and I had to come up with a workaround, which was to really open up my Jupyter and Python instances prior to start prior to installing CNTK, and because if you open a new instance of a Jupyter notebook after installing CNTK, then a lot of those libraries stop working. So that was, not optimal. And again, I think it's not quite ready for the enterprise, but it's powerful though. Uh, the data set that I used was the banknote authentication data set that's available at University of California Irvine archives. It's a pretty popular data set, although it's smaller, only 1372 records. But again, this approach can, I have actually personally used it on much larger data sets, but for the purposes of a demo, this data set seemed to be optimal. Um, and again, the as far as the attribute information is concerned, we use the variance, skewness, kurtosis, and entropy of the wavelet transform image as the part of the features that we use to come up with a machine learning model. And then the classifier was again whether the banknote is authentic or fake. Um, Demonstration. Let me jump into the Jupyter notebook actually, because I think that does a much better job than the PowerPoint, and it's easier to sort of follow along. The so I'm going to start with the references or the imports up top. Matplot library, which I had already spoken about. NumPy, Pandas, pretty standard. Python helpers that are being used for data analytics, and then the actual CNTK libraries. So we started off with the data by reading the data. We read the data in the CSV format. I defined my column names, and then I used the pandas get dummies function, which categorizes the output class, and then I'm just printing out the various columns for both the features and the labels. I have set a random seed value of 11. The reason being, I want to get the same data every time I iterate through this. It just helps train and tweak the model better as you are in the training phase, so that you get the same set of data every time you run through the program. So I split my data into the train and the test data set. It's pretty standard 80-20 split. I then sort of separated my features and labels for both the training and the test data set, and you're just seeing some additional details about my data sets. In terms of the configuration for my neural network, so I had 4 input dimensions, and I had 2 output classes. So this was, again, a binary classification problem. But it's very easy to, have. I've even used this model with 100, 110, 120 input variables, and it seems to work out fine for binary classification. Number of hidden layers, 2 and 50, and I experimented a whole lot with these variables. Number of hidden layers means the actual number of hidden layers that are in your neural network. Number of hidden layers dimensions variable is basically the number of nodes in each of those hidden layers. And then this is a key CNTK context, which is really the input container in which we fill the various data points in the sample. And then this is where we start building up the neural network. So you define your linear layer, which is really where we multiply the weights and the features, and we add the overall bias to the term. Then we come up with then we have the dense layer, and this is where we apply the activation function. In this case, we are using a sigmoid function, but we can also use a tanh function or other functions. And then finally, the fully connected classifier network. So again, the input of the first layer is the output of the first layer is the input of the next layer, and in this case, we only have 2 layers, but the idea is that you can have as many layers that you want as you need to train your model. So this is a good way to understand what the different layers are and how the network works. But the same can be accomplished just using the create model method that is defined below, and this is accomplished using the layers library. So CNTK has also has a primitive besides the primitive functions that I defined above, it also has a layers library, which makes it very efficient and convenient to define neural networks. It's a faster, easier mechanism to define neural networks, and think about it as sort of like building blocks or application building blocks. And again, it can be used to define any neural network that exists. So again, the same thing is accomplished in a much smaller with fewer lines of code essentially. And then I define my loss function using a cross entropy with the softmax function. Um, then my determine my classification error. This is again I'm instantiating my learning rate, and this is something that I experimented with a whole lot. In this case, I'm using a learning rate of 0.05, and then also define a moving average function so that we are keeping track of what our average is as we are learning with the model. And then just additional debug statements around the training process. The mini batch size, that's important. 2 is relatively small, but we have a smaller data set. I would have, and then the total number of batches are going to be 548.5. But again, I've used this with much larger sample size, and usually it's more around the batch size, probably about 30, 40, 50 params, or not params, but number of samples. And but again, that's roughly, you should probably look at the number of mini batches should be anywhere from around 400 to 500, upwards to about 2-3,000. That should be the number that you're looking for. um, and again, we can't really print the output at every single step, so I'm just printing it at every 20 steps. Actually, not even that. I'm just printing it towards the end of my training cycle to just. Otherwise, it's just very time consuming, and for debugging purposes, it's valuable. But all I wanted was my error for rate for my last iteration, so that's what I have over here. And then this is where really the action happens. This is where we are sort of training the model, and once we train the model, then we use the matplot libraries to plot our graphs. This is like a very it's a extremely valuable utility and comes in very handy for machine learning. So again, it plots the overall loss and the prediction error, and both of these graphs are trending significantly downwards as we are training the model. So that's a really good sign. That means our model is highly accurate. And then once we have that, then we sort of run the test features and the test labels, and we determine, okay, now we have trained our model. Now let's run through some test cases to make sure that we have actually trained our model. So that's what we're doing here. And as we run the mini batch with the test labels and test features, again, the output for the error rate is about 0.014. So that's 99.98% accurate. So that's pretty good. And then I'm just sort of printing out my labels and the predicted data sets, and as you can see, they're pretty close. I think if you look closely enough, you might be able to find out subtle differences. Probably two or three values between the labels and the predicted outcome is different, but I'm not gonna go down that path um, now because I've already done that a whole bunch of times, and it's not easy on the eyes. Um, so uh, so this was part two of my presentation. The only things that's left is the actual demo of the working code. So I'm going to be following up with another short video, but that'll be really short, probably a couple of minutes. It doesn't take long for to get through this data set. It's a extremely small data set, but again, the learnings are powerful, and this same code base can be used for much more complex data sets, and I've already done that on multiple data sets. Thank you.